All right, so this is going to be number 13 from the review, and I'll do each one of these questions individually because they are a little bit big. Additionally, it says at the end of this problem just to check your answers using technology. So I've got Desmos open. We'll do that at the very end, and I'll show you visually that our intervals make sense. Okay, so unlike the equalities, which we would have studied in class, like you can't cross multiply when you have inequalities. Okay, so what you'll notice when I did question 11a or something like that, I brought the 2 over first and then I found the common denominator. That's because it's same kind of practice with the inequalities. So I'm just going to bring the 2 over and I'm going to get something like 3 over x plus 5 minus 2 has to be less than 0. Okay. And then I need a common denominator, so I'm just going to go 3 over x plus 5 minus 2 times x plus 5 over x plus 5 has to be less than 0. Okay, and then I'm going to get, now that the denominators match, I can just kind of write the numerator in one numerator and over one denominator now that the denominators match. And so I'm just going to write this 3 minus 2 times x plus 5 over x plus 5. That has to be less than 0. Okay. And then I can distribute the negative 2 onto the bracket. And so I'm going to end up with something like this. So 3 minus 2x minus 10 over x plus 5 has to be less than 0. Okay. And then I can collect any like terms that are in the numerator. So 3 minus 10 is going to be 7. So I'm going to have basically 2x minus, or sorry, negative 10 plus 3, right? Is going to be negative 7 over x plus 5. That has to be less than 0. Okay, we discussed in class, I'm just going to take this opportunity to talk about this. Negative, I could factor a negative out of the numerator, and I'd be left with 2x plus 7 over x plus 5 is less than 0. And then we discussed in class, like when we've worked with inequalities in the past, if I were to like try and get rid of that negative, I divide both sides by -1. And we discussed in class, or multiply by -1, we discussed in class that when we do something like that with inequalities, I'm going to be left with, I need to flip the inequality basically, right? And so you can see here, like if I were to just leave this negative 2x minus, sorry, negative 2x plus 7 over x plus 5. You can see that these two things are kind of, well, not kind of, they are vertical reflections of one another. So basically what's going to happen is we're going to take this graph over here, we're going to vertically reflect it, okay? And then all of the intervals that we find for this graph have to reverse because this thing over here would be the vertical reflection, okay? And so what I'm going to do is maybe just avoid flipping the inequality because we're going to get the same kind of, it's the same graph, but it's just been vertically reflected. And it just changes the intervals. So the graph we are producing is kind of like this one here. So I'm not going to flip the inequality here. I'm just going to leave this. And now I'm going to find the areas of interest in which I'm going to check the intervals. Okay. And so you'll see when we did that, we drew a little number line. Okay. Like an X number line. And then I put the areas of interest on. And those areas of interest came from our x-intercepts and our vertical asymptotes. Okay. And so we would have a vertical asymptote, as you guys would know, at x equals -5. Oops. Okay. And additionally, there's an x-intercept that comes from the numerator, and we would say 2x plus 7 would equal 0, or you could even put the negative out front of it, right? And then you're going to divide both sides by the -1, and you're just going to be left with 2x is going to equal -7, and then you divide both sides by 2, and you'd be left with x is equal to -7/2, or -3.5, right? So I'm going to have an x-intercept here somewhere at -3.5 and 0. Okay, and so what I'm going to do now is just check the intervals. Okay, so I'm going to just put in some values of x and see what comes out for values of y, and I'm not actually too worried about the magnitude of those y values, just more the sign of them, right? And so I'm just going to try to evaluate if this thing's going to be f of x. I'm just going to evaluate f of x at a bunch of strategic values, right? I'm running out of room. Let's go. Okay, I'm just going to evaluate f of x at a bunch of different x values, strategic x values that fall within those boundaries. So here's boundary 1, boundary 2, and boundary 3. Those are the intervals that I'm checking to see where the graph is going to be positive or negative, so that I can ultimately satisfy the original kind of inequality that was stipulated in the problem, right? And so I'm just going to go, let's say a number in the first interval would be, say, something less than -5. So I'm going to say, just to make it easy, like -10, right? So I'm going to get, sorry, that should be in brackets. Right, over -10 plus 5, right? And so that's going to be -20 plus 7 is going to be -13. Times the -1 up top is going to be +13 by -5 in the bottom. So that's going to be a negative entry there, right? So you can see in that particular interval, our y value is going to come out to be negative. Okay, and then in the second interval, again, I'm just really worried about the magnitude, right? Not so much the actual value. But if I put in a number like, let's say, -4, that's kind of a nice number between -3.5 and -5. That can evaluate the function, right, accordingly. I'd get -4 plus 5. So you're getting a -8 plus 7 is going to be -1 times -1 in the top. It's going to come out to be positive over positive. Okay, and so in this interval, the graph comes out to be positive. Okay, and I've got one more to check. I'm just going to check f at something bigger than our x-intercept at 3.5. I just checked 0. 0 is bigger than -3.5. And so I'm going to get -2 times 0 plus 7 over 0 plus 5, okay? And I'm going to be left with -7 over +5. And so that interval is going to be negative, right? And then so I could actually just depict or say or describe where this graph, I'm going to say f of x, because the original problem is like, where is this thing going to be less than, well, 2 eventually, but I'll show you that in a minute graphically. But where is this graph going to be negative after I do kind of some isolation for things, right? So particularly actually this statement right here. So where is the graph or the equation less than 0? Well, you can tell me the function's going to be less than 0 on this interval, -infinity, can't encompass -infinity, all the way up to our vertical asymptote of -5. And then it's also going to be negative on the interval of, and because it's not less than or equal to, I'm not going to use a square bracket. It's just still going to be a round bracket. It can't be at -3.5. So we're going to say round bracket, -3.5 to infinity. Okay, so that answers this problem in terms of where this graph is going to be less than the other one. Now, what they like to do in Desmos, which is what I'll pull up now, is you can actually graphically show, and what this is asking is, where is this graph, this 3 over x plus 5, where is it less than the graph y equals 2? So what I'm going to do over in Desmos now, I'm just going to make this bigger, is I'm going to actually just put those two graphs in the Desmos on the same screen, and then we're going to see on what intervals is one less than the other. Okay, and hopefully they match the intervals that we just drew or described or found on the last, like algebraically. So I'm going to go 3 over x plus 5. Okay, so we're over here. You can see there's the vertical asymptote. And then additionally, I'm going to put the graph y equals 2. Okay, and just to help us, I'm going to actually just put the x equals, like the vertical asymptote, -5. Okay, so there's our graph. That's what that thing looks like. And with the addition, like if I didn't have the y equals 2, that would be the rational expression. It'd be a horizontal asymptote at 0 and a vertical asymptote at -5. And then I'm just going to turn on the y equals 2 again. So this is the question that's asked of us. Where is the green graph less than the purple one? Well, it looks like if I said on the domain, which we said on the domain from -infinity to -5, that's where the green graph is going to be less than the purple one. I can kind of see that. And to do that, Desmos does this kind of cool thing. I can actually put an inequality into Desmos and say, you know, x is less than 5, -5, sorry, and it'll highlight it for me. So that actually confirms, you can see there that the graph is indeed less than the purple one on that interval. That's what we said with this first one. I'll highlight it in red on the, over here. Okay, you can see that here. That's the red interval that we described. Okay, and then additionally, we said there was a second interval where the graph was going to be less than 0 after we did some isolation, but ultimately the 2. So I'm going to say x has to be greater than. Now, here's the thing. Desmos is, it'll show you a point of intersection right there. You can see -3.5 and 2. So that's pretty good. So I could say x is greater than -3.5. There you go. So again, you can confirm that in the blue, the graph is indeed less than the graph y equals 2. Okay, and then in the middle, that's where the graph would have been positive. That's where we identified that number 2 interval. I'll highlight it in yellow right here. Okay, where we said it was going to be positive. Okay, so long story short, I suppose maybe avoid changing the inequality because now it's you're kind of talking about the intervals for the vertical reflection. Just leave the thing alone and just kind of find the initial inequality without flipping the inequality. Okay, so you see all our algebra checks out against our graph, and that's it.